So with that, one of the other technologies that we're going to be talking about is BSS coloring. And Nate, I know that you've looked into this a bit. If you wanted
Yeah.
to, you know,
Yeah.
talk through some of the detail.
Yeah. So the way BSS coloring works is there, and it all kind of goes amongst what we were discussing from the OFDM side of things, where everything kind of builds on each other within the standard or within the specs. There's a there is a way that the wireless devices communicate their existence to each other and manage the shared commonality between them to set up a perimeter, right? It's the way things are handled on the back end. If you think about management domains within wireless, right? And if I'm somebody who wants to connect to a wireless network within, say, a Starbucks or something, you go in, you get a coffee, you sit down, you want to maybe do some work, right? A lot of things are going to go on behind the scenes. There's going to be your laptop that you just fired up that you want to type that term paper, or you want to get the spreadsheet together, to send off to the company. As soon as you fire up the wireless station, it has to establish some parameters, right? It has to understand what type of data flow that it can accept, what type of or am I going to be able to talk A, am I going to be able to talk G, maybe I got an old access point that I can only talk B, that type of thing. So it's got to establish it's got to kind of have a handshake with the wireless environment around it, right? So Starbucks has a wireless access point, that wireless access point supports G. It doesn't support B. Your laptop supports B and G, right? So you start talking with these things called beacons to the access point, and the access point says, within these beacons, hey, okay, I noticed you can talk B and G. I only talk G. Let's kind of hook up on this G, and then we'll figure out the rest as we go, and then more information comes down the pike, right? The problem that you face is that there is other things sending these BSs as well, right? Like, say, the yogurt shop right next to the Starbucks starts sending out BSSs because they have a wireless access point too, but you don't want to connect to the yogurt shop, right? You've had your fill of Dippin' Dots later or earlier in the day. You don't want any yogurt, so you're gonna not want to deal with that. But you're still gonna hear the beacons, and you're still gonna have to make an educated decision on what to do with those beacons, right?
And hold on, when we talk about those beacons and BSS, that BSS is basic service set, right? So, um, is this the same as an SSID? That's is that basically just the identifier for a network? Is there a direct correlation between BSS and SSID?
Well, it's all kind of within the same. It's all just pieces of information from an advertisement side of things, right? It's almost like a billboard that an access point puts up to let all its wireless clients know what it's capable of doing. Included in that is the idea of an SSID, right? Where you have the ability to connect to a particular SSID at a particular data rate over a certain band, right?
And this
And
comes from each access point. So every access point offering this is
correct.
sending out the same information, and then the client chooses which one to join. But you
Yep.
have it, as Nate's saying, it's coming from this access point, but it's also coming from the one down the hall.
Right. Exactly. So back in the day, right, what would end up happening is the way this would impact things, right, is that uh, uh, the Starbucks wireless access point, somebody just bought a brand new wireless access point, put it in, it's running AC, it's running a band only, maybe it's running a GN type thing, a bunch of, cool alphabet letters, right? And then, but the yogurt shop is running a B, right? That's it. They got they took a wireless access point from the late 90s, as a cool toy, and they just threw it up on the network. What ends up having to happen, or the way things were inefficient um, up until the introduction of AX, was that you had to deal with that as the person sitting at the Starbucks, right? You needed to deal with your neighbors before you could jump onto the network and do anything of significance. And the problem is there wasn't a good way to handle that back in the day. So what would end up happening is you would sit there at your desk looking to communicate with your access points. You would start to hear these BSS frames coming into your device. Your device would have to deal with them. Some of them were elegant as the years went on and were able to get around things, but the oldest specification wins. So that antiquated B band that was being sent out in the BSSs, uh, everything in wireless was slated toward being able to handle the maximum amount of devices. What that means is the lowest common denominator always wins. So your workstation was having to deal with these antiquated B frames that were coming in. The way that would usually shake itself out was a degradation in performance. Okay, so the way things are moving within the AAX paradigm is there's this idea of coloring, right? Where in essence it's a way to set up a perimeter that's relevant to you within a same physical space. So if I have an AX access point and I have an AX network interface card and I establish connectivity, say I walk into that same Starbucks, I sit down, fire up all my stuff, get a mocha latte, and I'm ready to do my business, right? So I fire all that up and I want to connect, right? There is, uh, whenever your card starts to talk, what it's going to be able to do is it's going to be able to do additional checks within the BSS frames, or within the BSS paradigm. This whole idea of this 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 spatial area that receives beacons, to where it's done at a higher level, to where it can kind of ignore the yogurt shop now, right? Where these frames that are coming in from the yogurts, they're still coming, but you can make a concerted effort to say this isn't what I'm a part of. um, and it kind of boils down to the idea of a VLAN structure, right? That's the way
Okay.
I look at it. Where on it's somewhat of a dumb thing, right? Where you're setting up these highways, like Joe had alluded to before, where you're back in the day, like to your point, Jeff, whenever there was this hub idea, right, where everything was, it was a gang mentality or it was a mob mentality. When you plugged into a port on a switch that was a 24 porter, you became part of that 24 port existence. Like you were a community with the rest of those devices. As time went on and you started to introduce switches, you became a singular entity within that community. You could work autonomously. They even went a step further with VLANs, where now you could take that autonomous system and you could put logic over that to go back to say, okay, maybe I'm a group of 4 now, or maybe I'm a group of 5 out of 24 ports, versus an all or nothing sort of thing. It's kind of the same way, right? Where now you're sitting there, you're receiving all this information. So it's not really high end technical, but you could say, okay, I'm a part of this community now, whether that be the Starbucks community. I don't really have to deal with the frozen yogurt community anymore, right?
Yeah, that's interesting. I mean, I think that the VLAN analogy is interesting because it is doing a piece of tagging, but maybe it's a little bit different because in VLANs, that's how we separated out segments of the network, right?
Hmm. Yeah,
Different layer 2 domains.
yeah,
With the way that the BSS's coloring is added, it's actually being done by each individual AP, right? So it's actually a way for you to be able to just pay attention to your AP or listen to other APs that are also part of your network,
yeah,
right?
yeah.
So like it's just helping you give you another way to differentiate between overlapping APs on the same channels, I would think. But like the
Yes.
tagging piece, it definitely I think is kind of interesting. Like that analogy about the VLANs.
Yeah, if you look at it, I would say that, and again, it's just an analogy. It's just a way
Mhm.
to kind of bring some ideas home. But think about, if you want to even take the VLAN analogy a step further, say the frozen yogurt place is VLAN 200, and anything within the Starbucks infrastructure. Say you got a big Starbucks, right, and it's part of Target, right? So you're
Which is
in the
inside of
Target,
another Starbucks.
sure, sure, just nested Target Starbucks overlays everywhere, right? So, say all of that, all the Target Starbucks mega store is VLAN 100, right? You just want to talk to VLAN 100 while you're in there, and you want to ignore VLAN 200, which is the yogurt store. It kind of boils down to that.
Hmm. So in the end, so what is it going to mean from a design perspective for us with with having that additional coloring? Is it something that we're going to configure? Is it just going to be is it going to be part of the secret sauce? Have you seen anything on that front? Like, are we going to be also assigning like specific tags to APs, or is it just going to? Do you think it's going to be done under the
Good
covers?
question.
Yeah, it is a good question. There, I, I think we're all going to be cognizant of it. I think it's going to be something that we're going to have to track. For instance, like a channel width, like our older example, or the example we just went over with. Obviously, we have to know what the length of a channel width is on a particular band that we have in play. Whereas maybe 20 years ago we didn't have to know that, right? We're kind of in the same boat now, where we're going to have to understand these ideas of the way things communicate, as far as PPDUs, which are kind of the if you in spanning true world, a BPDU, it's basically just a layer 2 identifier packet, right?
Mhm.
We're going to have to understand some things about that traffic now. Um, as far as the understanding that I'm receiving certain PPDUs within my space, whereas I'm aware of other PPDUs that I'm not making sense of or I don't care about. That whole idea wasn't relevant within the last standard, right? A beacon was a beacon, right? Now we're having to understand that we have relevant beacons to our environment, and then we have foreign beacons. So it's another piece of information that we're going to have to be aware of. The configuration itself, the Cisco controllers are, everything's going to kind of have a footprint. So there really isn't going to be a ton of hand holding of the environment. The footprint will be established by the perimeter itself. But within a spectrum analysis, within trying to understand what's around me from a perimeter that I do not manage, you're probably going to have to be aware of that traffic, right?
Some of the stuff that I've seen that's kind of interesting is talking about deploying this like inside. If it's rather than having a couple different organizations that might be in different spots with different SSIDs, but even in like a corporate environment, I'm kind of curious about the channel reuse aspect of this as well, right? So if you do one of the things that's interesting, and we'll talk about it a little bit later, but Wi-Fi 6 is also both 2.4 gig and 5 gigahertz capable. So, it plays in both frequency spectrums. But what I'm hoping that we see with the deployment of this is that you could have a deployment of APs. And today, historically, if we're just talking about 2.4 gig, we only have 3 channels to deal with, right? Trying to keep things so that you don't have co-channel interference with only 3 channels is tough. When you go over to 5 gig, there's a better chance that we're using 40 megahertz or 80 megahertz channels. So even though we have tons of options, there's still potentially a lot of overlap. But I think it's kind of interesting in some of the spatial reuse aspects of the BSS coloring is just being able to say, okay, we'll just deal with the 2.4 gig just because it's easier with 3 channels. Um, that we could have, channel 1, channel 6, and channel 11 on these APs, but maybe we have 10 APs on this floor. Having each one of those APs that are that are labeled as channel 1 having that different BSS color, that different tag, actually should let clients communicate to each one of those APs without stepping on each other, because the kind of the assumption is that the client will have enough information about what both of those are to be able to communicate with that color packet, so that the clients on the other side of the second AP don't need to worry about it, right? They're not going to see the packet coming from the client attached to this AP over here, but this AP or this client is going to know about both, and it could actually make a choice to change the color to send it to this other AP as it moves. And hopefully what that'll allow us to do is actually in 5 gigahertz, it should really help us, with potentially doing high density deployments. But even in a 2.4 gig range, there's so much co-channel interference today. Any mechanism that we can have to allow
Yeah.
some of that overlap
Yep.
to have less impact to the clients, I think is a big benefit. I mean, because 2.4 gig is a mess.
Yeah, I mean, if you think about it, well, two comments on that, right? The first one kind of being relevant to what you just said, where, if you think about it, if you compare it to a layer 2 environment, right, on the wired side, whenever we first started this out, to your point, we had hubs, right, where hubs were extremely chatty, whereas everybody was, if there was something that was layer 2, um, without a unicast destination, right? It went to everything. So, as switches moved on, the switches gave the capability of sending this unicast information only to certain individuals with this idea of a VLAN, right? So the overall, if you think of a switch or a layer 2 device with um, inefficient traffic. That's kind of how this scales, right? Where hub was 100% inefficient traffic. Then you introduce the switch with no VLAN and it went down to 90 or 80. Then you introduced VLANs. You reduce inefficient traffic more, right? So you're taking the overhead from the network as a whole and you're reducing that footprint. And that's where you're taking the performance. That's where you're gathering the performance. And that's how you did it on the layer 2 switching environment. And this is how kind of you're doing it on the wireless environment as well, where the BSS becomes the VLAN in that paradigm where you're reducing inefficient traffic. The interesting thing though is this can't work in a vacuum, right? So the BSS can't work in a like if I were to just introduce the BSS within, and that was the only change I made, this really wouldn't do much of anything but reduce a small level of efficiency in the overall structure of things. The beauty of this is literally the 4 boxes and many other boxes that we're going to go over with the AX spec, where the OFDMA, the MIMO, all that kind of comes together to take its particular lane, make it more efficient, and at the end of the day, you have this compounded efficiency variable that makes AX shine as it progresses, which is the where the bang for the buck comes in.
Yeah,
Which is
I
cool.
can imagine that we're gonna be talking about this stuff for a while.